In this video, we will show you how to get started with the PIC32MZ DA Curiosity Development Kit using MPLAB Harmony version 3. If you are new to Harmony version 3, be sure to watch our video, How to Set Up the Tools Required to Get Started with Harmony version 3. This project is based on the PIC32MZ DA, our MIPS core 32-bit microcontroller. For this video, we will use the PIC32MZ DA Curiosity Development Kit that includes an integrated graphics adapter for interfacing the microcontroller's built-in multi-layer graphics controller and 2D graphics processor. Let us look at the resources available on the board before we get started. The PIC32MZ DA Curiosity Development Kit contains a PIC32MZ 2064 DAR176-I2J microcontroller with 200 MHz, 2 MB flash, 640 KB of SRAM, and 32 MB DDR2. Users can add functionality through the Microelectronica Micro Bus Click interfaces. There are two X32 32-pin interfaces to support audio codecs, DACs, and Bluetooth radios. The board also has a CAN interface, an Arduino Uno interface, and I2C-based temperature sensor. The extension headers are useful to connect a variety of Explained Pro extension kits or access the I/O pins of the PIC32MZ DA microcontroller. There's a modular Ethernet PHY system that enables different PHYs to be plugged into the board. Onboard 8 MB QSPI memory, and an I2C-based serial EEPROM, which can be used to store the application data. This EEPROM has a factory-programmed EUI48 or EUI64 address, plus an embedded unique serial number. The graphics interface enables the use of graphics cards for applications requiring display capability. There are 4 user switches, helpful in reading user inputs. A micro USB connector to connect the PIC32MZ DA Curiosity Development Kit with a PC. A 2.5mm barrel jack power input. The board contains an onboard debugger for programming and debugging. And the onboard debugger interface also acts as a virtual COM port. A user RGB LED, which is useful in showing the application status. And finally, a micro SD card socket is available on the backside of the board, behind the Micro Bus 2 interface. To get started developing applications on this board, open the PIC32MZ DA Curiosity Development Kit webpage and download the Getting Started demo project. The PIC32MZ DA Getting Started zip file has the demo firmware, and you can extract it from there. Open the project in MPLAB XIDE. Go to Tools, Embedded, and open the Harmony 3 configurator. The project graph is opened. You can see the various peripherals configured for the PIC32MZ DA microcontroller under this demo project. Clicking on a peripheral block shows you the configuration done for that peripheral. By clicking on the TMR1 or Timer1 peripheral library, you can see the Timer 1 configuration is set to generate 500 milliseconds of timeout interrupt. By clicking on MHC, Tools, Pin Configurations, under the pin settings you can see the switch configuration to read the switch SW1 and SW2 status change. To configure other necessary system-specific configurations like the clock or DMA, go to the Tools menu under MHC and choose the system module you would like to configure. For example, to configure the clock, open the Clock Easy View window by clicking Tools, then Clock Configuration. Here you will see the main clock is set to the default clock frequency of 200 MHz. Using this Harmony configurator, you can easily add another peripheral, reconfigure the project, and generate the code. You can go to the project configuration path and check the various files to understand the implementation of the project. This code sends the strings using UART on a periodic basis, and the periodic timeout can be changed by the switch 1 press. Also, the demo application prints the current room temperature periodically using an onboard temperature sensor. To run this demo project, connect a micro USB cable between the debug USB on the board and a PC. This enables the programming of the microcontroller and provides a serial connection with the console device. In MPLAB X, under Project Properties, select the Curiosity PIC32MZ DAR as the target kit in the Connected Hardware tool dropdown. Then click OK. Open a terminal application, such as TerraTerm on your PC, and perform the serial port setup. You can now build your project and program the PIC32MZ DA Curiosity development kit by using MPLAB X. Here, you can see the LED toggling rate text printed on the console in a periodic basis. The periodicity of the timeout will change from 500 milliseconds to 1 second, 2 seconds, 4 seconds, and back to 500 milliseconds every time you press the switch SW1 on the PIC32MZ DA Curiosity development kit. The demo application has additional functionality to print the current room temperature periodically using an onboard temperature sensor when pressing switch 2. The demo project shown in this video is also available on GitHub. Go to the link shown here to open the MPLAB Harmony Reference Apps repository. The applications to demonstrate the basic and advanced graphics capability on the PIC32MZ DA family are available under the path shown here. And finally, here is our MPLAB Harmony landing page, where you can find all the information about Harmony version 3. Thanks for watching.